Well, welcome everyone to this fantastic webinar on xenotransplant. I'm super excited to see all of you, and thank you for attending time on your Wednesday evening to join this absolute stand-up lineup, especially those that are on the East Coast and way into their evenings and enjoying maybe an early supper or cracking open a drink to enjoy this next hour of sensational information. My name is Shams Al-Akia, and I'm the Chief Medical Officer of CareDx, and it's an absolute pleasure to be with you. As we try and do this webinar, just a few housekeeping rules to optimize the best meeting practices. And so just to make sure the chat is working and we can be as interactive as possible, I'd love you all now to tell me, what did you get up to in spring break? As a Brit, I didn't grow up with spring break, and so I had no idea that each and every one of you have a spring break in a different week, anytime from the end of February all the way up into the middle of April. And so would love to see what you guys have been up to. And so please put in the comment of what's top of mind for you today. What have you been up to on your spring break? If you've had one, if you've got little ones there near, but no break here. Or in terms of how you're feeling today, are you feeling spring? Are you ready for Easter? Are you excited about Passover? What are you excited about for as we go forwards? Phenomenal. No break. There's a lot of people working really hard here, but with no breaks. I feel like we should move you all to England. There's lots of holidays. Stayed home for spring break. Very relaxing. Keep isolating. Smart. Yeah, still a bit of a scary time. Hey from Fairfax, 26 years out. Congratulations. Amazing. Oh, look, some shout outs to our guest up lineup. Okay. And with that, we'll definitely crack on and get to the meat and bones of what's happening. And so we want this to be interactive. And so if you have a question top of mind, feel free to use the chat function. You can put it directly to the panelists, or you can put it to the panelists and attendees. And so you can see the options of how to scroll down there and actually get your question into the pool. We're going to try and get through as many questions as possible. Quick disclaimer that, from our side, we are a company, and so we're not giving medical advice. A lot of the things that we're talking about today are super exciting, but also very forward-looking. And I think that's something that we do want to be open about, that xenotransplant, there's a lot to learn about and a lot to do. And I hope this excites and invigorates all of you to think about more about what's potentially possible in the transplant sphere. As we now go on and see today, we've done the chat, we are excited about how people are feeling, but also understand that everything that we're doing is around a patient. And so a chance to connect with you is the reason that we get up and come to work every day. It's the reason that I'm here and this panel is here, but also to think, how do we continue to move things forward for the transplant patient? How we can continue to make impact, how we can continue to come up with new ideas to innovate and put the patient front and center of everything that we're doing. In that instance, for those that don't know CareDx that well, you can see the company tends to grow with time, and you can see that a lot of the offerings are a combination of digital tools, pieces of software, molecular blood tests that keep you well in the pre, peri, and post-transplant period. We hope one day that xenotransplant will join this family of tools and be there, but also exciting to understand that how some of these tools can help the research that now is being done by these centers and companies to move the needle forward and help us understand how can we continue to make impact. And so a lot of you are now being very cautious with flares of COVID coming back, and I'm just hearing that New York might be going back into another rise of cases. And so we're excited to know that RemoTrack is still available for anyone that wants to have their blood drawn at home. That's possible. And so definitely please reach out to your practitioners to connect and give you optionality. We want to be able to keep you safe, and so we'll continue to run RemoTrack as long as you need it. And so those that have enjoyed it, I hope it has been helpful to support your care. And for those that are curious to understand, is there a better way for me to get my blood tests, an easier way, definitely have a look at that. Going forwards, the app is something that is new, available, and free to use. Again, has some great information and information about new webinars that will be coming up in the future. A great way for you to empower and take control of what's important to you with your transplant health. And so visit the App Store, download it, but more importantly, give us feedback. This is definitely version 1, and there's going to be some kinks in it, and we want to make it better. We want to make it the most useful thing that you guys are using. And so anything that you have to say about the app, we want to hear about, so how we can continue to move the needle on that front. And with that, I'm going to hand over to our co-presenter and partner for this webinar, Jim Gleason, who's the president of TRIO and also a heart transplant recipient. Jim, over to you for a quick introduction for TRIO.
We are TRIO, Transplant Recipients International Organization. I'm president of that organization for the past dozen years, and we are the voice of the transplant patient, and very proud to work with CareDx in support of the patient and adding the patient voice to things like the development of the app that Sham was just talking about. And so introducing TRIO, we were founded by Dr. Tom Sarsel and patients 35 years ago in 1987. And we are dues-paying members in local chapters and members at large across the country and in Japan. And thus the word international in our title, Transplant Recipients International Organization. Currently, we're in an upswing in terms of our assets and our impact, and that's speaking well for the patients. And then our mission, we're basically a nonprofit international organization committed to improving the quality of lives as touched by the miracle of transplant through support, advocacy, education, and awareness. And so we are widely recognized and respected as the leading voice of transplantation across all the organ types. So you do have organizations that are focused on one particular organ. We are covering all the organs. And through the TRIO headquarters and a number of chapters and members at large, TRIO serves its members in those 4 areas of support, advocacy, education, and awareness. Our major projects in recent years, one, we are a sponsor for Team USA at the World Transplant Games and the Transplant Games of America. Most recently, we've been developing an educational resource for post-transplant patients, making sure they're aware of the higher risk for cancers after transplant so that they can get treated for that and live a long life despite being high risk for cancers. We maintain a video presentation library, which currently has 179 video recordings of presentations by medical professionals to support groups and interviews. And that's available through YouTube, and it's also available through our website, which is trioweb.org. We have a United Airlines partnership program that's helping provide free air transport for patients and their families in need. And we are currently planning a virtual nationwide transplant support group. This is something that we find a need, and we're trying to figure out how to do that. And so if you want to get involved with TRIO, reach out to us, as I said, on trioweb.org or on Facebook, Twitter, Instagram, and LinkedIn, and join TRIO as a member on our website, or you can contact a local chapter. And so my own background with xenotransplant goes back to back in, I guess it was April of 2006. I was on a panel at a high school education about organ transplant, and one of the questions that came from the students was, what about xenotransplant? And I have to tell you, in 2006, there was nothing going on that I knew of. And so my answer was, I don't think that's viable anymore. I don't think there's any work going into it. And then we jump forward to July of 2019, and Bob Montgomery, who we'll hear from shortly, hosted a dinner in New York City for patients to come in and talk about xenotransplant and basically how would we get patients to accept a transplant from an animal. And I got to tell you 2 things I went away with, which were very surprising to me. One, the topmost reason people would accept it is they had the recommendation of their doctor. And the second was, if they had, that was the last resort option. In other words, they were so sick that they really didn't have hopes of getting a transplant. And so this became, as we've seen in recent cases, the last option they had. I'm very excited about the recent xenotransplant successes, both with the kidney research that Bob Montgomery has been doing in New York, and also the heart transplant news from a pig down in Maryland. I keep in mind, these are due to very sick patients, and so they're usually short-lived at first. These are not your typical transplant patient. These are patients that are so sick that you really wouldn't want to use them for a test, but that's the ones you've got, and it makes it possible for long-term use later on after this gets progressed. And so if you're familiar with the history of transplant, you know that it has a history of dire challenges. Those pioneers in the medical practice often are vilified and have a long-term rough go making it work in the beginning. And so I'm very excited to hear from some of the technology here, especially my friend Bob and Mike talking about what this is all about. Sham, thank you for that opportunity.
Thank you so much, Jim, and definitely it's been a privilege to partner with TRIO, and we can't speak highly enough of your organization and everything that you've done personally for transplantation, and definitely encourage everyone on this call to connect with TRIO and definitely learn more about them, and definitely echo those sentiments. xenotransplant has always been around the corner. We've heard that more times, but finally, ladies and gentlemen, that corner, we're going to actually see what's behind it. And it gives me great pleasure to welcome our two speakers that are going to tell us the exciting innovation that has happened that we've been waiting decades to actually see about and learn about. And so I'm going to let our speakers introduce themselves in more detail, but an overview, we have Dr. Bob Montgomery, who is the Director of Surgery at NYU and led the team that did the first human xenotransplant using a pig kidney. We also have Dr. Michael Curtis, who's the president and head of R&D of eGenesis, who is an organization and company that's really thinking about how do we bring this technology and scale it to help serve patients. And so with that, we'll hand the mic over to let them do a deep dive and drive straight in. Dr. Montgomery.
Thanks, Shyam. And I want to thank CareDx and Trio, for this opportunity to speak to my fellow patients and to, I've been looking at the chat and been very excited to see the anniversaries and people telling their stories. It's so wonderful and heartwarming, and to see some of my patients actually who are in attendance and who I remember very well some of the challenges that we face together in your transplants. So it's very exciting to be here tonight. Probably many of you know that I was at Johns Hopkins for about 30 years, and then in 2016 moved up to New York to the Big Apple, the show, and I've been here building a program, working on new challenges in transplantation, and at the very front of that is xenotransplantation. And so I'm really excited to be here tonight. I think a lot of you know that I am a recipient of a heart transplant in 2018, and I'm doing extremely well. I had a hepatitis C organ, as probably some of you in the audience also helped to pioneer. And it's a really exciting time for transplantation, because I think we're in the process of really addressing the #1 unmet need in transplantation, and that's the organ supply. So we're all very aware of this. We all had to wait for an organ. I had some very scary experiences before I finally was sick enough to be listed for a heart transplant. I had 7 cardiac arrests, and I'm very fortunate to be here today. But as we all are acutely aware, there are a lot of people who aren't here because they became too sick or died before an organ was available. In fact, about half of the people who are listed for a transplant never make it across the finish line. And that's what we're talking about tonight. We're talking about new opportunities that go beyond what we currently have in terms of organs from other humans. I think both xenotransplantation and perhaps bioartificial organs, which are a bit further away, but these are renewable sources. I think about them as the solar and the wind of organ supply. I look forward to a day when there's no limitation in the number of organs that are available to patients, and we can begin to transplant some of the 800,000 people who have end-stage renal disease, rather than just the lucky few, the 90,000 that actually make it on the list. And again, remember, only half of those ever get a transplant. So I'd like to see us meet the needs of the people on the list, but go beyond that and consider xenotransplantation as, a very viable source of organ replacement.
Amazing. Thank you so much for those comments there, Bob, and echo those sentiments. We'd love now to introduce our second speaker for the webinar and panel, and that's Michael Curtis again from eGenesis, who's the president and head of R&D. Michael, tell us a little bit more about you and the organization.
Yeah, happy to, and thanks for having us join you guys this evening. We are a company that was founded about 7 years ago, involved in applying modern genetic engineering and molecular biology, and I'll talk a little bit more about that in a moment, to creating porcine donors that can kind of address what Bob was just talking about, right, to address this organ shortage challenge. And I think we have a longer term goal of, can we actually engineer porcine donors to actually obviate the need or reduce the need for immunosuppression? I think both of those goals are in what we're trying to accomplish, both solving supply and reducing immunosuppression. So I come to xenotransplantation as a drug developer. I've been in the biotech pharma industry for about 30 years. I've been fortunate enough to be involved in taking over 14 products into the clinic. I've had about 5 drugs that I've worked on have been approved to help patients, and that's really the whole point here. And when I looked at the progress in xenotransplantation over the past 10 years, you could see inside that the foundation for a real product. And that's why I joined eGenesis, was to turn this idea, this really science fiction idea, into products that can benefit patients. And for us, to Bob's point, there's so many patients in need, and can we create a product that is good for patients, right? It's not just a science experiment, right? We have to create products that help people and help patients. That's what eGenesis is really trying to do. So the hope is, by bringing this experience working with both new products, working with the FDA, that we expect to, in the next couple of years, really be prepared to run a formal clinical trial. For eGenesis, our lead program is for kidney transplant. We have some very encouraging data in monkey models of renal transplant, where we now have recipients in the monkey model that are now over 500 days post-transplant, which is incredibly encouraging to us. We're preparing to go to the FDA this year to have a discussion with them about what they would need to see to perform the first clinical trial, the formal clinical trial. And we're leveraging the pioneering work that Bob Mohammed has done at Maryland, Jamie Locke has done at UAB, of these early pioneering experiments in xenotransplantation. Our goal is to run a formal clinical trial under the review of the FDA.
That's amazing. Well, I mean, very exciting, and I don't think we could ask for 2 better experts to help navigate these great questions. And I think with that, we're going to dive straight into the first question, and maybe that we'll hand that one over to Bob. Maybe you could start off by just giving us a history of xenotransplant. I mean, the concept's pretty old, and I think probably a lot older than some of us give credit for. And Jim sort of led into it, saying, why is he so excited and so many of us so excited about what we're seeing in the news today?
Yeah, so Shyam, as you said, that the concept of xenotransplantation has been around as long, maybe longer, than allotransplantation, or receiving another human organ. And it's faced a lot of challenges. The primary challenges, were this this response of what we call hyperacute rejection. So if you took an organ from, let's say, a pig, and hooked that up to a human by circulating blood through that organ, it would be immediately rejected. And the reason why is that there are some sugar molecules that were lost during evolution from pig to human. And we have what are called natural antibodies. A large portion of our circulating antibodies are directed against these sugar molecules, because they're also shared by molecules on the surface of bacteria. So our immune system is sort of primed to fight bacteria, but unfortunately, it's also primed to reject an organ from a pig. And so, some of the initial attempts at xenotransplantation were using primate organs, because certain groups of primates have also, lost those sugar molecules, and so we don't have that hyperacute response if you use that primate organ in a human. But I think primates really, I think the public perception is very poor of using primates as donors. But we all remember, for instance, baby Faye, or many of us, and that was a baboon heart that was transplanted and lasted for a while, again, because it didn't express those sugar molecules. But I think, it became clear that because of the scarcity of primates and how close they, the fact that they are closer to humans in evolution, that it was just really not an acceptable alternative. And, pigs, because they have large litters, they're used as a food source, they're relatively easier to genetically modify, and they're less likely to transmit diseases, were chosen. And then, there was a concern for a while about a particular retrovirus that is present in the pig genome. And I think that put a real damper on xenotransplantation for a while, even though there's never been any evidence of transmission into humans. And we've lived very closely with pigs for centuries. And then there was a study to look at all the people, over 200 people who had received cells or skin grafts, islet cells from pigs, and there's never been an instance of transmission of this disease, but that really slowed things. So why now is there's this sudden flurry? Well, this is often the case with major developments in science and technology. There are people sort of quietly working on these problems, and they often converge to a moment in time where a number of different groups simultaneously, make some breakthroughs. So that's why there's this kind of flurry of activity, I think.
That's amazing, and thank you for that overview. I mean, so exciting to see the rationale of the primate, and then moving on to pigs, and then seeing the advances there, and maybe moving on and with that vein of thought that you've started there, Bob. Trying to understand, Mike, when you now think about the strategy of looking at the pigs, and Bob sort of outlined the reasons and rationales why they would be the right animal to be using. How easy is it to modify a pig and genetically engineer one of these organs?
Yeah, no, it's a great question, and really to kind of leverage what Bob was saying, there's been a lot of evolutions and progression in genetic engineering tools to allow us to edit genomes generally, right? People probably hear about CRISPR, Cas9, it won the Nobel Prize. It's a huge breakthrough in our ability to edit genomes. So there's been several technologies that have allowed us to go into the porcine genome and make edits to address some of the incompatibility that Bob was talking about. Like, so for instance, when we have these differences in sugar molecules in the porcine donor tissue versus either a non-human primate recipient or human recipients, that leads to acute rejection, right? We know what those sugars are. So we can go into the genome and we can make changes that really eliminates those sugars, right? And what Bob and the recent experiments have shown is that by making those changes to the pig genome, we can eliminate hyperacute rejection, which was a huge, I really can't be overstated really how big a step that was, because if we can't overcome that, then we have no hope of long-term survival, right? So now that we've overcome that, the pig genome also allows us to add, to make additional modifications. So in the case of, for instance, our donors that we're making eGenesis, we make 3 modifications to improve the consistency or compatibility of the carbohydrates or the sugar molecules. We also add human transgenes, right, to the porcine genome to promote compatibility between, for instance, the coagulation system, or the blood between the recipients and the donors, and the porcine donors. And then the other thing that we do, and Bob talked about this potential retrovirus, is we use CRISPR-Cas9, so this modern engineering tool, to make mutations in the retrovirus to reduce its ability to be transmitted to recipients. So we reduce the risk of that virus infecting recipients. And the porcine donor is a really ideal donor because it allows us to do all of this engineering. There's another technology that we couldn't do any of this without, if you remember back in the 90s with the cloning of Dolly the sheep. The way we make porcine donors is a very similar technology, right? So for us to go from a single cell and then use a cloning technology to make a porcine donor, if we didn't know how to do that, we wouldn't be able to make porcine donors. And so it really is when we think about editing porcine donors to provide as sources for organs, it's this combination of technologies and breakthroughs over the past several decades that have led now to us being able to make porcine donors that eliminate hyperacute rejection, have transgenes that can promote long-term graft survival, and give us a chance. And we see this when we study this in primates in transplant to get long-term graft survival. Right. So when we go into our first clinical trials, we have a reasonable expectation that porcine donors that carry all of these modifications, those organs will last a long time and make a difference for patients. That's the point. I think all those technologies coming together is, as you can imagine, is not trivial. Takes a while, but there have been breakthroughs in the past 5 years that have allowed us to make donors with improved compatibility by making edits to the porcine genome. And then the last piece about why pigs as donors is we obviously know how to make pigs at scale, right? So we can grow pigs in a way that is pretty unique. From the agriculture industry, we've been making pigs for a long time, right? So we know how to make many of them. So if you think about the goal here is to produce many organs to help many patients. The pig is almost the ideal species because of the compatibility between the physiology, the ability to edit, to improve compatibility, and then the ability to make them at a reasonable scale.
That's phenomenal, Mike. Thanks so much for that. I think one of the key things that we're understanding is that the technology is moving at an exponential rate. And I think what you're highlighting is some great advances that we've all seen in the news. We all remember Dolly the sheep and all this news now about CRISPR-Cas9 and the way that sequencing is now changing the way that we're looking at all these things that are possible. There's some questions in the chat that I'd love you to maybe ruminate a little bit and we'll answer at the end. But, on that, do you envisage think about the potential of modifying an organ, a porcine donor organ specifically, and creating a personalized sort of organ for a personalized recipient, truly sort of tailoring each organ to each recipient? Is that possible? And is there any benefit? Could there be any modifications? And a question just for clarification, there is no human DNA that gets modified as part of xenotransplant. It's one of the questions that came in the chat. I think maybe we touch on that now before we get into the next round.
Sure. So first on the personalization, I think when we think about eGenesis making a donor, most of the folks in the field think the same way. We're trying to make a universal donor, right? So we're trying to make a supply of organs that would be suitable for everyone. There are ideas about how you could maybe tailor. And one of the big questions still in the field is what are the right types of edits to the genome to get that long-term graft survival? So what is the right combination of taking things out of the porcine genome, putting things into the porcine genome that's going to lead to long-term graft survival? We actually don't know the answer, but we know that at least what we're doing now looks promising and has the potential to lead to long-term graft survival. As far as our edited porcine donor having any impact on the human genome, post-transplant, as far as we can tell, we don't expect any. The biggest thing that we're focused on, and Bob mentioned this retroviral transmission, is we want to make sure that we produce donors that are clean of any kind of what we call adventitious agent. So viruses, bacteria, anything that could come from the donor tissue into the recipient. So we spend a lot of time at eGenesis and a lot of our other colleagues in the space making what we call clean donors, right? So we produce our porcine donors in really well-controlled, clean facilities to keep them free of all these infectious agents so that the recipients don't receive them.
Well, this sounds terribly exciting. I think, very optimistic in some of these things happening. But what do you see in terms of the barriers in terms of xenotransplantation? What comes top of mind as you now think about the challenges of, engrafting animal organs into humans and thinking about some of these modifications that Mike's speaking about in terms of potential things that we need to be more thoughtful for?
Well, I'd like to, speak first of all about sort of more practical barriers rather than the scientific side. So, I'm an animal lover. I wanted to be a vet, most of my life until my dad got sick with the heart disease that I inherited. And then I shifted, to taking care of humans. But, I think it's really important to say that the pigs that are being raised for this purpose are treated very humanely. And I've just been amazed at, the company that I work with and the other companies, just how thoughtful they are about this, and the fact that they provide play and toys and things like that for these animals. It's a really different experience, I think, than food production. And I think that they're living their best sort of pig life, if you will. But that's a really important thing. Public perception, transparency, really being very clear about what we're trying to do here, and that, we're doing this in an open way, and we're really considering patients and what can benefit society the most. So, those are important barriers. And I think also just getting the attention of the people who make decisions about priorities in healthcare. And the government is a very important part of that. And I think patient advocacy is extremely important. I mean, the reason why we have a treatment for HIV now had everything to do with the patients, the early patients who had HIV, and how strongly they advocated for a cure. That's why the government got together with industry and with investigators and academia and found treatment after treatment for HIV. It was because of those patients making their feelings known and really being tremendous advocates for advances. We need the same thing in xenotransplantation right now. So I'll have Mike, maybe talk a bit more about some of the, the technical aspects of the barriers.
Absolutely.
Make sure whatever products we're building as a company fits the patient's needs, right? And so the patient voice in the development of what we're making is super important. So when we set goals for like durability of survival, what are patients looking for? Clearly, we're looking for an organ that you get once and never have to look back, right? But to get there, we're going to have to take some baby steps first. As far as the animal modification goes, I think the field has made a lot of progress in identifying what kind of modifications do we need to make to the porcine genome to give us long-term survival? So can we turn the porcine donor into a robust, durable donor? The verdict is still out of how many modifications it will take. I think we've, again, had very good results in primate models where I think we're ready to go to the clinic and ask the question, how do these modified organs perform in transplants in patients? I mean, we hope they perform as well or better than they've been performing in the primates. But that said, we're going to learn something from those first clinical experiments that will surely inform what kind of edits we need to do next. So we can keep developing in primates forever, right? But we need at some point to make that transition into a clinical study to really understand where we are. Because with the new technologies, in the limit, there's really no limitation to what modifications we can make to the porcine genome. So at some point, we need to be well informed about what those modifications are and what the benefits are going to be, for patients receiving these organs.
That's amazing. And Mike, I think what I'm hearing from both of you is really that advance in terms of the science and the potential to tackle these barriers really is that partnership between practitioners, scientists, and patients. And really that pinnacle of that partnership is really what's allowing xenotransplant to move forward. And as we think about patient advocacy, I couldn't think of anyone that was probably more apt than having Jim on the panel here and say, Jim, would love to kick it over to you as you now sort of think of the patient as a patient. How do you feel about the future of xenotransplant? And when patients now think about the need of transplant, do you envision maybe the sickest patients on the list needing xeno, the maybe the healthiest are now listening to some of these risks and benefits? What are your thoughts on the landscape as it's here?
I'm not alone in being very excited. Personally, as I approach my next year's birthday, is going to be 80 years old and almost 30 years post-heart transplant. I never thought I would live to see this in my lifetime, to be honest. This is front page news today. The subject of recently, this one is even the 4th webinar event on xenotransplant. My only caution is my optimistic survey for common use recently was I chose this would be common use maybe 7 to 10 years from now. And in talking with a couple of industry experts since then, they are saying the same thing. I know, even talking to Mike yesterday, he was actually even more optimistic than I was, bringing it down even closer. And I'm very pleased to hear that, given what he's doing. And Bob Montgomery, same thing. We're in the decade where we may see this to be a common use, and that is very exciting. But at the same time, you need to be patient. As I said earlier, early transplant innovation years tend to have a rough history. When you read the history of transplantation, the early pioneers were not accepted well because they had to choose the sickest of patients to use the new technology. And those sickest of patients, while they lived, didn't live long. And their own community vilified them for what they were doing, killing patients with their practice. And yet it's because of those pioneers and those patients who agreed to undergo those initial pioneering practices that we have the results we have today, where most organ transplants are getting above 90% survival rates. And so as Bob Montgomery exhibits, and as the heart transplant down in Maryland does, these are successes. People may say, well, he died. Well, we're all going to die someday. But look what the pioneers have done in giving us hope for the future. So in summary, I'm very excited, and the people I talk to are equally excited about what's going on here, and really can't say enough about the pioneers that are making this happen, and for CareDx for getting this message out so people can see the hope that's coming forward.
Thanks for those thoughts, Jim. Really appreciate that. And I think when we really think about the potential here and the excitement, I mean, one of the key things I think Bob talked about early on is the organ shortage. I mean, how much of a problem is that? You know, you mentioned patients are dying actively on the waiting list, and this now is a potential resource. Could you maybe take a little deeper dive into that and say, you know, how could this potentially be a strategy for scale to really address that shortage?
Sure. People die all along the journey at various time points, toward transplantation. And, unfortunately, a lot of those are kind of not well recorded. Those deaths are, they're sort of silent. As a transplant surgeon, what's most visible to me, and what I kind of see right in front of me are the results of the transplants that I actually do and that my colleagues do. But I challenge my colleagues all the time to think not just about the outcomes of the people that were lucky enough to get a transplant, but all the people who didn't make it to that point and weren't that fortunate. And I think those lives are just as meaningful and should be just as visible to us, as the people who might have, died after a transplant. So, I think that it'll be a long time before a pig organ has it as good an outcome as a human organ. We've been doing, human transplantation, transplantation between humans, what we call allotransplantation, for a very long time now. And, as Jim said, the outcomes are extremely good. And it's going to be hard to, reach that level, right away. It's going to take time. But, as Mike said, there are some things that we can do with pig organs that you just can't do, with human organs, in terms of making them more compatible, having them, available when you need them, not just when you happen to be lucky enough to be at the top of the list. And providing a transplant earlier in the disease process, where you're more likely to have a successful transplant than when you're really ill. So I think, for a while, the organs will be used, probably the pig organs, in folks who are less likely to receive a human donor transplant. But then as we get better and better at having success with xenotransplantation, I would see it as an option for any patient. And I think patients, for instance, if you're a young person and you have end-stage kidney disease, you're probably going to need several transplants throughout your life. And I could see people going back and forth between pig organs and human organs, maybe receiving a human organ early on that is more likely to last longer, and then maybe as they get older and are more likely to die from something else, you know, maybe it would be more appropriate for a time for a pig organ.
That's great. And thank you for sharing those thoughts. I mean, I think we kind of understand that value proposition, and it's really interesting to hear you speak about how you can potentially have a normal human transplant, still be eligible for a potential xeno, and then flip-flop between the two. I mean, really interesting thoughts there. Mike, as you kind of think about the shortage, but also maybe, you know, you alluded to this earlier in the conversation, that clinical trials and going to the FDA within 12 months. Where do you see the future? And if you now have to peg timelines on this sort of idea of addressing the organ shortage and really moving the future into today, where do you see this going?
I mean, I think initially, I mean, riffing off of Bob's point about giving options to patients who currently don't have options, right? And I think that's where we're going to start, right? And see how successful we are there. And so, and clearly there's a tremendous amount of unmet need in patients who just will never receive an allotransplant offer. And is the xeno product out of the gate suitable, right? Does it produce a good enough outcome that patients should spend their time on it? And I think if that turns out to be true, and that's our goal in the first trial, right? Our goal is at least 1 year post-transplant function of the kidney, right? In the kidney program. The goals are different in heart, and they're different in liver. But I think if we can achieve that goal in our first trial, I think that is a transformational moment in transplant, because to going back to some of what Bob was saying, when you have this kind of option, how will you use it? It won't be don't do allo. No, of course, allo still has the best outcomes, and that's still the best option for patients. But how do you get patients to that allo transplant? Right now, kidney patients spend lots of time on dialysis. Could we have a porcine organ that would allow patients not to go on dialysis, right? That they could spend time on a xenotransplantation while they're waiting for an allotransplantation, right? That alone could significantly improve outcomes for patients. And so that's the type of thinking that we have. Like when we bring this product to this field, it's almost, you don't exactly know how it's going to be used, right? Because there's options that the physicians, the surgeons have never had, right? Maybe you don't need a year. Maybe 6 months is sufficient to get you to an allo, depending where you are. So the future, creating this optionality, right? It could be a complete transformation of how we think about solid organ transplant, having an option for patients that currently don't have one.
Great, thanks so much, Mike. Jim, you sort of spoke about the shortage, and also saying that you never thought you'd see xeno in your lifetime. As you see the future of xeno now and hearing the conversation, what would you like to see, and what does the future mean to you in terms of xeno, in terms of next steps?
I would say the word is hope. Today we have over 110,000 candidates for organ transplant currently on the wait list. Xenotransplantation would be a major game changer with potential to drastically reduce that list and save so many lives. I mean, the limitation today is the availability of organs. Being able to grow organs through pigs, as an example, that is such a game changer and brings hope to so many people who are not, I mean, it's tough waiting on the list. And if you're a kidney candidate, you're talking maybe 5, 6, 7 years of waiting. This would totally change the field, and that's where the big hope comes into. So I pray that all of the people involved in this are successful and are giving hope to a community that really needs it.
Thanks so much for those comments there, Jim. Okay, well, now we're going to move to the audience questions. We're excited for this quick fire round. So each of our speakers has 30 seconds to try and get through as many questions as possible. We're super excited that you're a really engaged audience, and we have a ton of questions to get through. So I'm going to crank these out as fast as I can, and we're going to go all the way to the end of the clock here. So the first question we've got held up here is to say that, is this something, do we think, that's going to be requested, or is it going to be only for a subset of patients? Do you feel xenotransplant will become the mainstream, or will always be potentially for that subset? Bob, do you want to kick us up on that?
Yeah, that's going to be a moving target. I think in the beginning, it's going to be for subsets. As we get better and better at it, it may be the choice. Okay.
Mike, any thoughts on that one from you? Do you think a subset, or do you think for everybody?
Well, I completely agree. We're going to start in the subset, and if we have good success, it will broaden out. Yeah, okay. Absolutely.
Next question. So we are trying to estimate the longevity. If you can genetically modify the organ, can you also make it more resilient and sustainable? Is it possible that xenotransplants could last longer than human transplants? Mike, do you want to take that one?
I mean, in theory, it's possible. I mean, the age of a pig, depending when you receive your transplant, right? We're talking 15 to 20 years potentially of a porcine organ, which I think is putting us at the long end of allotransplantation, human-to-human transplantation. So we may be limited somewhat in durability. I think we would all agree if we're at 15 to 20 years post xenotransplantation, we're doing pretty well. And I think the other advantage of xeno over allotransplantation is the potential to get a second organ, right? Because supply, again, isn't limited, and the genetics are they're consistent, right? So you'll receive a very similar kidney if you receive a second kidney. Your body will already be used to the first kidney.
So the patient that had the first heart transplant received a different type of immunosuppression. Do you feel that patients that have a xenotransplant will require different medication to those that have human transplants? Bob, any thoughts on that?
Yeah, so apropos to the last question and this one, I mean, there are groups that are looking at ways of either modifying the genome of the pig or transplanting thymus or cells from the pig to induce tolerance. And, the hope eventually is maybe we can do things with a pig organ that we can't do with human organs in terms of modification that would allow us to reduce immunosuppression. But in the beginning, it's probably going to require more immunosuppression. And yes, you're right. In the recipient of the heart transplant, there were some additional drugs that you're probably not familiar with that were used for that patient.
Fantastic. And a follow-up question to that, is there a chance that xenotransplants increase your risk of rejection compared to a living donor or a deceased donor human transplant? Any thoughts from you, Mike or Bob? Who wants to take that one first?
I think based on what we know now, yes, it's likely that the first generation xenotransplants will not be tolerated as long as the current allos are, right? So you probably, if the primate models are predictive, we would expect rejection sooner than you would with a well-matched allo, right? And the goal is, like, we don't know as we go into the first clinical trial, just what's the delta? Like, how quickly will these xenografts be rejected, right? The hope is they won't be rejected at all, right? But the data says they probably will be. The question is how much post-transplant function can we achieve? And then that will feed back into Bob's point. We can continue to engineer, but knowing what happens in recipients in the first year or so post-transplant is super helpful to figuring out what to do next as far as the engineering, which is why there's an iterative process here that we're in the beginning of.
Phenomenal. Okay, our next question. What can patients do to help advocate in kickstarting this movement and moving the science along? Jim, what are your thoughts on that?
Oh, first, let's get the education that we're sharing with these webinars so that they can be the spokesman for this technology, which is coming to life. And when the conversation comes up, as I said, this is front page news. It's exciting, and people are talking about it. And so making it real and being educated about the potential by listening to, surgeons like Bob, researchers like Mike. I mean, this is where you find out what's really going on and can affect how people react to this concept.
Phenomenal. Bob, maybe with your hat on as a patient, how would you want patients to advocate for this going forwards?
As I mentioned earlier, I think, the HIV story is a really good template. The patient group should look at how HIV patients really affected change. There's the government, there's the insurers, there's the various branches, the NIH, Medicare, what we call CMS. These are the stakeholders. These are the groups that need to be approached, but they need to be approached not on sort of a one-off, one patient at a time, but through advocacy groups. So it's pulling together, it's banding together, it's making your desires and your thoughts and your hopes known to the key people. Phenomenal. And this could be done through things like TRIO, organizations like TRIO and others, maybe Absolutely. With the help of a company like CareDx.
Well, we would love to help all the organizations in any way that we can. And so if there's definitely anything we can do, we will definitely do that. Okay.
Can I just mention one other thing, Sham? The technology, that brought us vaccines and, and different drugs for the pandemic, it was a top-down thing, right? That came from the president and filtered down. I think xenotransplantation advocacy is going to go needs to go in the other direction. It needs to come from the patients and from the researchers and upward.
Well said. And I think definitely grassroots movements have always been the most strong and definitely helped us do things the right way. And so I definitely echo those sentiments. Okay, we have a two-part question, and Mike, I'm going to ask you to tackle it because there's a bit of a deep dive here. So there's some work on growing organs. What are your thoughts on stem cells to grow organs using scaffolds? Where is the overlap with xenotransplant or competing with xenotransplant? Is there room for both technologies, or could these complement each other in a way?
Yeah, no, I think those are much earlier technologies. And when you look at the complexity of a kidney, for instance, and the different cell types that are inside a kidney, repopulating a scaffold, I think will get you to a certain level of function, but it is really hard currently to recapitulate or reproduce what you see in a true, kidney that was, developed inside a full, either a porcine donor or in a human. So I think I can't tell how far away it is from reality. I think it's a great idea. I think there's similar to the breakthroughs that we've been talking about that have been enabling xeno. I think the world of repopulating scaffolds needs a few of those similar kind of transformational breakthroughs to make it a reality. And I think for each organ type, it may have a different probability of success. I think there's something there. I think it's definitely worth pursuing, but I think it's quite a ways off.
And the next part to that question is, how long does it take to modify an organ, and how quickly do you see this to be able to scale? Like, what sort of volume do you think you would reach in 3 to 5 years from now?
Yeah, so our goal now is, from an engineering perspective, the first donors that we are currently studying and taking to the clinic took us about 3 years to make one donor. We have newer engineering technology, it continues to evolve constantly, where we can make a new set of genes, we can make a new porcine donor in a matter of about 3 to 4 months. So that's evolving. And then the ability to take that donor and scale into production, we would expect in the matter of the next 5 years, if we have good clinical data, that we could be talking about producing, several thousand donors a year. I mean, that's the idea. And you look at the unmet need and you say, well, that's still not enough. And it's not. And this is where, if we have some success, the investments would be made to start to scale it even more significantly. And the challenge for us as a company is we need to show that the technology is beneficial to patients. And if we can do that, then the investments will come.
That's amazing. So the next question comes around matching. So I'm going to kick this one over to Bob, because I know he's also been an advocate for good matching. Does the importance of HLA match or tissue or blood match have the same rules as a human transplant when considering a xenotransplant?
So it does seem to be different. The targets, of the antibodies that we see between human and pigs are different, and many of them are unknown. Whereas human to human is primarily the HLA locus, and we know more about that. There are probably more targets between a human and a pig than two humans. But there are things you can do. For instance, you can have, a herd of pigs that we used in our first transplant are all blood type O. So you can do things like that, that make them more compatible. So you don't have to worry about blood type incompatibilities because you're, in that case, those pigs were bred rather than cloned, which is a nuance. But that kind of thing is possible to make them even more compatible eventually.
That's great. Well, look, we've got 5 minutes left and we've got 5 questions. So you all now need to hold your breath and talk as fast as you can, right, to get through these next 5 questions. So the next question comes up and says, when do you think the next clinical trial for a patient to be able to enroll in will happen? How far away with it, and how could we get information about it? I'd love to put that to all of you, because I'm sure there's 3 different advantages to that. So Bob, maybe just with you, kick us off there.
1 to 2 years, I would say.
Great. Jim?
I want to agree with Bob. I'm an optimist, and that is awful aggressive, but I think that's fantastic.
Yeah.
Okay, aggressive but agrees.
Yeah.
Okay, Mike, what are your thoughts?
Yeah, we have a plan to start a trial in the next 2 years. So if things continue to go well for us, and we have good interaction with the FDA, our data continues to look good, we expect to start a trial in the next 2 years.
Okay. But remember, those initial trials are going to be small.
They're small. Yeah, we're talking
about a handful of people.
Handful of people. Yeah, exactly. Yeah.
And so where will that, so following on from that, where do the trials start? You've done a heart, you've done a kidney. Is there plans to do a liver? Is there a plans to do a lung? Where does this stop? And will there be one organ that will take precedent over another? Mike, why don't you kick us off there?
Yeah, so, it gets challenging. And lung is more challenging than heart, which is more challenging than kidney. And they all have their different challenges. So the way we do it, ranked at eGenesis, is kidneys are priority, heart is second, pancreatic islet for type 1 diabetes, and then we have what we call an ex vivo liver perfusion, because liver is also very challenging to get compatibility between porcine donors and humans. But those are the four major organ types that we're working with, and they all pose slightly different challenges.
Bob, what do you think about that?
Yeah, I mean, I think lungs and livers have unique issues that haven't been overcome, but you could imagine also that in these organs that might not last as long, that they could be used as a bridge, because in the case of the liver, there's really not a good replacement. There's not sort of a dialysis that is broadly available, for people with liver disease. So maybe if the organ only worked for several weeks, that might be long enough to bridge somebody to a human liver.
Fantastic. Question about islets. Could you use xeno for islet transplant? That's just jumped in. Any thoughts on islets? Or is that far away?
Not far away.
It's already, it's already been done at some level, right? And so the group has already done wild type porcine islets with some success. And so we have an islet program where we're using engineered islets to, again, treat patients with type 1 diabetes. Yep. So it's in the mix.
Fantastic. Okay, so we've got a minute left and we're going to get a last question. One deep breath, make sure no one passes out. Okay, so as we now go into the last sort of next 12 months, what do you think you will see in xenotransplant over the rest of 22 going into the end of the year? Mike, what else can the public?
I think there is interest in more compassionate use studies, right? I think what the Maryland team showed was the potential benefit. I mean, that was a very transformational study for the field that could have potentially been very helpful to Mr. Bennett, right? And so I think they showed that it's possible. So I would expect that we might see some more of those type of experiments, small single one-offs before the first real trial starts.
Phenomenal. Bob, what would you like to see happen for the rest of this year?
Yeah, I mean, it's hard to know. It's hard to know whether the regulators have more of an appetite for those one-offs, or I think they seem to be very focused on the phase 1 trials. I think now is the time for us to roll up our sleeves and get the work done, and for the advocacy work to get the attention of the stakeholders, so we are assured that this is going to move along and move at the rate that we want it to.
Phenomenal. Jim, what would you like to see happen in the rest of this year?
I'm excited. There are so many patients that are not able to get a transplant today by age, by any number of factors. So as a last resort, I think you've got a lot of patients who would be ready to stand up and take on this challenge, even if it means, one patient once told me, as their lung transplant was failing, even if for one more day, I would do this all over again. And so that community of desperate people are going to grab onto this as big hope. And I hope that each one of them will contribute to the long-term success that we're going to see in the years to come. And I am so excited to hear both Bob and Mike predict trials the next 1 or 2 years. That's fantastic. And then common use sometime shortly thereafter. This is, we've got to be patient, but at the same time, you can't help but be excited.
Jim, you closed this webinar so eloquently. I can't really follow that. Hope and courage. What a great way to end this webinar. And never challenge these 3 panelists to a quick fire round because you will lose. You guys were rapid. So thank you very much for joining us with this hour of xenotransplant. I hope you all learned an absolute ton. It's been a privilege to host this webinar on behalf of CareDx and Trio. A big round of applause to our panelists. Thank you so much for giving up an hour to educate all of us. And thank you to Xeno and everything that you guys are doing for patients. Have a lovely evening. Good night. God bless.